Hey guys, welcome back. So today we learn another basic and interesting concept of Java, that is how do we prevent inheritance. The first question that would obviously come to our minds is that why do we want to prevent inheritance altogether? I mean, the Java designers actually provided us the concept of inheritance to make our life easy, and now we are studying how to prevent them. Why is it so? So we'll answer this question soon. First of all, let's quickly overview the concept of inheritance. I'm sure most of you must know it, but to give you a quick gist of what inheritance is, with inheritance, we not only inherit the functionality, but also extend and override the existing behavior defined in the superclass. So that's a quick gist of what inheritance is. If you have any doubt on inheritance, I would recommend you to learn inheritance first and then come on to this video. Okay, so why do we want to prevent inheritance altogether? Basically, there are certain scenarios when all the methods in a class are final. That is, we don't want any of the method of a class to be overridden. In such a case, we have two options. Either we can declare all the methods of the class as final, and whenever we'll add a new method, we have to make sure that we put the final keyword before that particular method, or we can restrict that class for inheritance. That is, if somehow we restrict that class to be inherited and we do not declare the methods as final, even then the methods could not be overridden because the class would not be extendable in the first place. So these are the scenarios where we want to actually prevent inheritance. Okay, so let's now jump on to the how part. That is, how do we prevent inheritance? There are two ways to prevent inheritance. The first way is the obvious way, and most of you must have guessed it. That is, we can declare the complete class as final. If we declare the class as final, that is, if we put a final keyword in front of the class, then that class cannot be extended. So a final class is not extendable but is instantiable. What does it mean? That obviously it would prevent inheritance, that is, it is not extendable, but a final class can have its own state and we could actually instantiate it and create objects of it. So let's quickly demonstrate this. So I'll just uncomment this code. Here I have two classes, class A and class B. I've declared the class A as final and I'm extending class B with class A. So I'm trying to extend the final class here. As we see, the compiler is throwing us an error. Let's see what the error is. The type class B cannot subclass the final class, class A. In simple words, class A cannot be inherited and you cannot actually subclass it. So the first part of our statement, that is a final class is not extendable, is proven. Next, we see that a final class is instantiable. So we can create objects of the final class. Let's quickly see. Here I'm creating an object of class A and instantiating it via the default constructor of class A, and the compiler is fine. It's not giving us any errors. So the second part has also been proven, that is final class is instantiable. An example of a class in the Java library that is final is string class. If we quickly see the string class, as we see, the string class is a final class, so it is not extendable, but we can obviously create objects of the string class, which says that it's instantiable. Okay, now let's quickly jump on to the second way to prevent inheritance, and that is kind of important because most of the interviewers play around the second way here. So the second way to prevent inheritance is via private constructor. That is, if our class is not final and we have declared the constructor as private, we'll not be able to extend our class in that case. Okay, let's quickly demonstrate this as well. I'll just comment out this code and uncomment this one. Okay, now we again have two classes, class A and class B. In class A, I'm declaring the constructor of class A as private, and we see a compiler error in class B. Before seeing the compiler error, let's quickly try to guess what the compiler error might be. So this is a question of constructor chaining, which we have already studied in the previous video. If you have already watched it, I hope that you guessed this correctly. And if you have not watched it, I would recommend you to pause this video here, go on to the constructor chaining video first, watch it, and then come back here and try to guess what the error might say without actually looking onto it. Okay, as we've already studied that whenever we instantiate a subclass, the compiler inserts a super invocation statement to the beginning of the constructor of the subclass. And the super invocation statement would call the NOA constructor of the parent class. So the state of the parent class would be initialized first, and then the state of the subclass would be initialized. In this case, whenever we create an object of class B, NOA constructor of class A would be invoked, and when the execution would come onto the NOA constructor of class A, it would see that the NOA constructor is private, so it is not accessible in class B, and that's why the object of class B could not be initialized. So let's quickly see what the error here is. Implicit super constructor class A is not visible for the default constructor. Must define an explicit constructor. So as the compiler says that the NOA constructor of class A is not visible, so either you define an explicit constructor or the inheritance could not take place. So as the constructor is marked as private, it can't be invoked from the subclass constructor that contains the super invocation as its first statement. And no constructor chaining means no subclass. So that's the reason that a class with a private constructor is not extendable. However, as we see that a class with a private constructor is neither extendable nor instantiable. So we cannot even instantiate a class with a private constructor. And why? The reason behind it is very simple, that the constructor is private, so it is not accessible outside the class. Okay, an example of a class of Java library that has a private constructor and is not instantiable is the math class. If we quickly see the math class here, we see that it has a private constructor, and what does the comment says? Don't let anyone instantiate this class. So that's very much correct. Class with a private constructor is neither extendable nor instantiable. Okay, as we have two ways now to basically prevent inheritance. One obvious question that could come onto our minds is that which of the two ways should we use to prevent inheritance? Basically, if the class should not be extended but has a state involved with methods depending on it, that is, if you want the class to be instantiable, go for the final class. Example, methods in the class string work on the input data. So we can instantiate the string class, and the data we provide in the constructor in the initialization is basically used by the methods of the string class. So if your class has a state involved, then you should use the final class, as final class could be instantiated. But if you are dealing with a utility class that has only static methods, then you can mark the constructor as private and it would prevent instantiation. Example, the math class, as you've already seen. So this was pretty much it about preventing inheritance. If you have any questions, I'll be happy to answer it in the comment section below, and I'll meet you in the next one. Till then, goodbye, have a nice day.